good afternoon, and welcome to the Saturday 4 p.m. social. My name is Jim. My call sign is Alpha 7 Charlie Lima, and I'll be your net control for today's session. This group meets on this repeater every Saturday afternoon at 4 p.m. The repeater operates on a frequency of 147.3 using a PL tone of 136.5. We are an informal gathering of ham radio operators directed by net control in order to facilitate the flow of communication. The purpose of this net is to encourage radio activity and discuss technical topics relating to ham radio with the group. Should an emergency occur during this net, we will break for that emergency and assist as needed. Is there any priority or emergency traffic at this time? All right, hearing none, is there an alternate net control for today's session? Okay, it sounds like you get me, and that's it. All amateurs are welcome and encouraged to check in and participate. To best achieve participation by all, we'll use a roundtable format. Once check-ins have been established, we'll rotate through that list of check-ins, giving each individual the opportunity to share information, ask questions, or make comments. The communication can be directed to the net or to the group or individuals. Please keep the information shared short so I'll have a chance to comment and participate equally. I'm doing my best to try to keep this to an hour today, so we'll try to keep it short. So with that, this is Jim, AA7CL with the Saturday 4 p.m. social, taking check-ins.
AA7WRU.
KD6EIR. K6RQD. AA7JS.
KD7ZPF, Russ, and I'll be in listening mode.
KF7OEQ.
Blue Charlie, George, Northeast, Grand Pass.
I think I doubled with George. KF7OEQ.
KJ7GUW, I'll be listening.
AF7QX, listening.
KJ7VZY, listening.
Okay, so far I've got Ivy, KA7WRU, West, KD6EIR, Ed, KK6RQD, Joe, AA7JS, George, KJ7 Zulu Charlie, Bruce, KF7OEQ, Russ, KG7ZPF in listening mode, Steve, KJ7GUW in listening mode, and Dennis, AF7QX in listening mode, and Glade, KJ7VZY. Did we miss anybody?
W7KRG, mobile.
Okay, Cameron, I got you in there. AA7CL in a group. Okay, last week we had about 17 check-ins so far. We've got 12, including myself. Any other check-ins for the Saturday 4 p.m. social? KF7CL taking check-ins for the Saturday 4 p.m. social. Anybody would like to check in, all are welcome. Okay, might be somewhat of a short net today. All right, is there any announcements from the group? All right, any upcoming events? Okay, hearing none. Does anybody, anybody that's checked in, anybody would like to talk about any topics? Do you have any topics for the group today? All right, well, hearing none, I guess you're stuck listening to me here for a little bit then. All right, well, last week we spent some time talking about digital multimeters and some of their functions. We went into some details about, you know, the different functions and what they might do and, you know, what you might find in a modern digital multimeter today. We talked about some basic functionality. We talked about measuring LEDs. I want to thank John, WA6IKO, for his input last week, which I found very interesting, and I learned a few things as well. But does anybody have any comments or questions about the discussion from last week? Okay, hearing none. Well, this week I wanted to talk a little bit about maybe some expectations. So one of the things I think is important anytime you're taking a measurement with your meter, it's important to have some expectation or understanding what it is you're actually measuring. And to kind of illustrate that point, imagine that you have a problem with your VHF radio here on the net, and you suspect that there might be some sort of a problem with your power supply. So you break out your new trusty digital multimeter and you knock off the cobwebs and you commence probing. And one of the things you do is you measure across the power supply output and you measure 11.8 volts. So what does that mean? Is this within specification? If you look at the front of the power supply, you might see something that says Astron across the front. It might say 35. Well, I think most of us would understand that 35 means that the power supply is rated for 35 amps. But what about the voltage? Is this a good reading? Does it, you know, should it be more? Should it be less? What are your thoughts? Somebody give me some ideas here.
A7JS.
I was kind of hoping I didn't have to start calling on folks. Thanks, Joe. Go ahead.
If nothing else, I'm brave. Well, I would expect, you know, something like 13.8 volts. You know, that's what I set my power supplies at. So 11.8 would definitely be on the low side.
Okay, well that's good. Anybody else have any ideas about that? So you measure 11.8 volts. What then?
7 NXT.
Hi, Dave. I've got you checked in. Go ahead.
Yeah, with the power supply, personally, I would try and go to the documentation for the radio and see what you actually want. But I agree with Joe, that does sound a little low, unless you're working with something odd. Most radios, mobile radios at least, are intended to be powered by a car battery or something similar. So somewhere between 12.8 and 14 volts, something like that, is what I would expect.
Okay, very good. Thanks for your comments and input. Yeah, I mean, I agree with you. And that's a good point. You know, our cars, last time you checked your radio, you had it in the car, and you happened to pull it out for today's session. But in the car, it seemed to work just fine. The car battery is 12 volts, right? So 11.8, that's pretty darn close to 12 volts. So is it okay, or do you need to go looking further? Anybody else have any thoughts about that?
I think ambient temperature, when you're making your reading, has a big effect. AF7QX.
Yeah, okay, that's something to consider, especially if you're measuring battery voltage. If it's 19 degrees out and you're checking your battery and your radio's operating on battery, I think temperature definitely is going to have an impact on that. All right, well, good comments. Anybody else have any ideas about this 11.8 versus 12 volts? What is a modern? Today's cars. What are the voltage operate? If you got the car running, what would you expect to see if you measure across the voltage if the car's running?
I'm thinking 13.8 maybe. Enough to charge the battery. It's always more than 12, that's for sure, right?
Yeah, well, I guess that's the question. So that's kind of what's bringing up this idea, and that's kind of what it is illustrating my point. The idea is you have to understand what it is you would expect, or what you should see when you're doing your measurements. Otherwise, the measurements are irrelevant. You really don't know, is it good, is it bad? What if we go back to Joe's statement? Joe said 13.8, and that's what he sets his power supplies for. What if it's 13.8 and you go to transmit and it's 11.5? What then? Anybody have any ideas?
EIR.
Go ahead, Wes.
Okay, if the power supply is supposed to put out, 12 or better, or 13.8 like Joe would expect, and the rest of us probably, it means there's some kind of a draw on the system, perhaps. It's pulling it down, maybe. And the reason why I'm conjecturing this is only because I had an old weak battery in my vehicle, and when I installed my radio, every time in the vehicle, the mobile rig, every time I started the car, it would reboot. So presumably it dropped below the threshold the radio wanted to see. And since it was a DMR radio with tons and tons of memory, with APRS and GPS and Bluetooth, it took quite a while to reboot. So it actually was noticeable. And oddly enough, I thought, well, I used the cigarette lighter adapter, and that's prohibited. I should have wired it right to the battery. That would have fixed everything. But when I finally replaced the battery with a nice, good, strong battery, the draw of the starter motor did not draw the battery down to a threshold that was below the radio's threshold to reboot. So anyway, I think that a lot of times when you see low voltage on a power supply, it might have something to do with the draw on the power supply. So maybe that would be another place to look. Am I on the right track? AA7TL and the group KD6EIR.
AA7CL. Yeah, I think you're right on target, Wes. Yeah, absolutely. So the idea, obviously, and some of this stuff is just kind of, we're putting it out there. Some of it's probably pretty basic, but it makes you kind of think about what it is we should expect. Dave, I think, put it pretty well in 7NXT. He said, well, he'd probably go and look at and see, well, what are the requirements of the radio? What's the minimum voltage, or what's required? You might have a power supply that says 35 amps or 35 on the front, so it's capable of handling up to 35 amps of current. But if there's a internal problem with the power supply and it's not regulating well, maybe you can only source maybe you can only source 5 amps. And so maybe it's completely fine if we're sitting there receiving, but the minute we put a load on that power supply, or a battery in this case that Wes mentioned, now all of a sudden that voltage drops below the minimum requirements of that radio to operate, which most radios today don't do well under 11.5 volts. 11.5 volts is probably absolutely a minute. They're not going to be efficient. Transmitter's not going to work well. And what prompted this power supply thought process was I've had several people contact me and ask me about their radio, and they say, I've got this new radio, or a new radio to me, and I've plugged it in and it works absolutely fine in a receive. The minute I key the radio, the thing powers off, or it reboots or resets, and then it just continues this problem. Well, sometimes it's a power supply, and sometimes it's a bad connection between the power supply and the radio. But if you don't have some idea of what you should be seeing, then the measurement's irrelevant. You don't understand it, doesn't make any sense, or you don't know if it's good or bad. So here's another thought process. Let's talk about batteries. We talked a little bit about car batteries. What should you see in a car battery without the engine running? What would be the minimum voltage you should see in that battery? Anybody got any ideas? What would be the
I guess it depends on if you left the headlights on.
Yeah, it certainly would, and for how long? Maybe a little bit of, maybe if you got done charging the battery for some period of time and you went to measure it, and maybe the voltage might be a little bit high, but what would you expect to see? What would be the minimum, Dennis? I mean, I know you probably know this answer, but if you don't, take a guess.
I'm guessing it depends on temperature, but I'm saying 11.5 volts might be the minimum. Just a little story. My wife's RDX needed a battery. I went to Jim Siegel, bought a brand new in the box battery, brought it home. It was dead out of the box. It would not take a charge. Brand new battery.
Well, geez, Dennis, you sound like that thing should last forever.
Oh, the new battery was dead from the dealer. And they periodically, I guess, recycle the trickle chargers on their batteries when they sit in the thing, but a brand new battery would not take a charge, and I returned it to the dealer and got a new battery, and it worked just fine.
AA7CL, well, I'm kidding, of course, and yeah, that's just kind of silly. You would expect the things to be fully charged by the time you got it, and a lot of those batteries do sit for periods of time, and in fact, the manufacturer, when I used to work in automotive, the manufacturers of the batteries said that we had to cycle chargers. Otherwise, if you didn't do your documented charging procedure, at least once a week on all the batteries, they wouldn't warranty them. So probably just sat there, and that's what happened. Very interesting. Okay, gee, I kind of lost where we were at here. All right, so we were talking about minimum battery voltage for your car. So most manufacturers, and this varies a little bit, but most manufacturers and car batteries say that an open circuit voltage, meaning no voltage on the battery, or no load on the battery, excuse me, should be somewhere around 12.5 volts. So if you came out and you wanted to check your battery in your car, the first thing you'd probably want to do is make sure, if you're going to measure the voltage, you don't have some load on it, interior lights or a hood light or something like that. But you should measure somewhere around 12.5 volts. If you measure below that, then it means that the battery is not, it's in a low state of charge, or it's weak, and you probably need to charge it. What about some alkaline cells that we talk about, or we use a lot in our old trusty DMMs, like maybe some double A's or triple A's, C's or D's. What would we expect to see on a new battery there?
A7JS.
Yeah, go ahead, Joe.
Yeah, I always check battery before I use it. I don't assume it works because it's out of the package. Typically, for a 1.5 volt, you'll see 1.6 solid. 9 volts, usually see 9 point something. And so that's what I normally see. A7JS.
Okay, anybody else ever test any of these batteries? And if so, what have you seen?
K6RTD.
Yeah, go ahead, Ed.
Well, I have a battery tester, and it's either green, yellow, or red. I know that sounds funny, but, red is dead, and yellow is, medium, almost dead, and then green is good.
That's what I like about you, Ed. You know this stuff, and here's the funny thing about your comment. I'm sitting here holding one of those battery testers right now, and I have exactly the same one. It says red is low, yellow doesn't say anything, and green is good. But what does that mean? So let's say the indicator when you put your AA battery across the tester and it's right on the edge of green. Is it really good? And what's the voltage of that battery?
Typically, my experience is that the closer to marginal, the worse it gets. So if it's touching marginal or it's right on the line between marginal and good, I'm going to throw it away. I'm suspecting it's below 1.5 at that point.
Well, yeah, I would expect that too, because the batteries only start out at like Joe says, 1.6 if it's brand new, fresh, and not been on the shelf for 24, 36 months. So 1.5 would be kind of right there. It's interesting because right before the net, I took my little power supply and I just set it to 1 volt to see where it measured, and it happened to be right on the line. So if it was 9/10 of a volt, it was in yellow. If it was 1 volt, it was right at the bottom of the green. And of course 1.5 was way up in the green. 1.6 was kind of the top. 1.7 it was probably pegged. But so the question is if it's in the green at 1 volt, is that good?
My experience, mostly with keypads and meters and the gates we have and everything, when the unit stops functioning, I'll go quick measure the battery, and chances are it's either at the line or in the marginal, and it's not good enough to keep, so I'll replace it.
Yeah, that makes sense. So do you use your little trusty red, yellow, green tester, or do you get the old multimeter out and test it?
For these kinds of things, I have a couple of those red, yellow, green battery testers. I don't break out the Simpson for those.
God, shame on you. Anyway, all right, well, thanks for your input. That's really cool. Anybody else have any thoughts about measuring batteries? Here's a question for the group. What about rechargeables? You've got a really cool little rechargeable battery. You went down to the store and paid, I don't know, what are they now, 20, 30 bucks for a AA? I don't know. But what about rechargeable batteries, nickel NiCad or nickel metal hydride? What do we typically see voltages on those? What would be a good voltage?
M7, NXT.
Yeah, go ahead, Dave.
Yeah, in my experience, the NiCads, the nickel cadmiums, they run 1.2, 1.3 volts for a good fresh charge. So they are significantly lower than a regular alkaline battery. I've never used the nickel metal hydride, so I don't know how they run N7 NXT.
Okay, very good. Yeah, so that's kind of interesting. You go down and you buy an expensive rechargeable battery and you charge it up, and you go to pull it out, and after the net that Jim talked about, all these batteries and what they should measure, and you measure it at 1.2 volts or 1.225 volts, and you might go, well, that thing's no good, I'm taking it back. Well, it's interesting that NiCad batteries that you buy that are rechargeable only start out at like 1.2 volts, so they're not even 1.5 volts. So that might play into some challenges if you have a device that you're trying to operate that requires a little bit more voltage. Maybe it drops out, at 1 volt. Maybe you might not get the life out of a NiCad battery because it doesn't have the voltage. 9-volt batteries, we didn't really touch on those other than just, kind of what the maximum is. But a 9-volt battery, if you measure one of those, it's, somewhere close to 9 volts when it's new, maybe a little bit higher. But it kind of depends on what you're powering. Some of these, a 9-volt battery commonly used in smoke detectors and things like that. I mean, they start operating down and around like 6.5 or 7 volts. So they'll run for quite some time down, from the 9 to 6.5 volts. Of course, they tell you to change them every year, but it just kind of depends on what the requirement of the device is, how much load it's putting on the battery and that sort of thing. So it's kind of good to know. And I guess my point in all this is kind of good to know what it is you're measuring. If you've got some resistance value, or maybe some voltage source that you're checking, you kind of got to know what it is that you're measuring and what's good or bad before you ever do it. Otherwise, you make the measurement and you're kind of at a loss for what's good or what's bad. Let's talk a little bit more about radios, ham radios, for a moment. I've got a 50-watt mobile radio here that operates on 2 meters. They say it's good for 50 watts. And reading the manual, it says it requires 13.8 volts. So what would you expect? I mean, I got a battery here that's showing 13 volts right now. What's the minimum voltage you think I could operate that at, and how much current draw should I expect from that radio? Yeah, go ahead, Dave.
Yeah, it's going to vary radio to radio, of course, but I would expect it to work in receive mode, like you mentioned earlier, down fairly low, the 11 volts or even lower. And depending on the radio, your power output may vary depending on your input voltage and the power supply's ability to provide power to the radio. The Q900 I'm using right now, for 2 meter, it wants 6 amps at 14.75 volts. So I just have to look and see what that thing set at for optimum power output. But for 2 meter, if I wanted, say, 12 watts output, it's going to want more like 16.8 volts, and is going to draw 7 or 8 amps for that. So the efficiency is going to depend a lot on it's going to dictate what's going on. N7 NXT.
AA7CL. Okay, very good. Yeah, I'm surprised that the voltage requirement's that high. Typically, once you get, a radio that's operating at 13.8, anything you start getting over about 15 volts, I think things can start to go bad. But yeah, you're right. As far as requirements, every radio is a little bit different. The transistors that they use and the power amplifiers in them vary in efficiencies. So, you know, you might have one amplifier that has a efficiency rating of maybe 60% on the final. Maybe you find another one that's, you know, rated at 50%. So, you know, a 50-watt radio really means it's, you know, 100 watts, you know, of actual source power to the radio, which means that, you know, 50 watts output, you're probably drawing somewhere around 8 amps of current. And if your supply can't source that 8 amps of current, then what happens is the voltage starts to drop off, and then as the voltage drops off, then you have moments of possible reset and things like that. Anybody other than Wes experience that?
M7 NXT.
Yeah, go ahead, Dave.
Yeah, I had a bad connector on my QYT radio, and it was a resistive connection, and so anytime I would try and transmit with it when I first installed it that way, the radio would reset. The voltage dropped or went too low. So that's reinforcing what you were talking about earlier, M7 NXT.
So more importantly, as we're discussing multimeters and measurements, how did you determine that?
I got out the meters and measured the voltage at the source, measured the voltage at the connector to the radio, and then, you know, did it in receive mode, transmit mode, and it was pretty obvious that there's, you know, a resistive connection problem there. And then I disconnected it and measured the resistance of the wire, you know, thinking maybe I had something bad, and very quickly found the bad connection.
Okay, so comparing the voltage at the source, or the power supply in this case, versus the voltage actually at the radio is how you determined that you could see that there was too much of a voltage drop. Are you familiar, or have you tried the voltage drop test where you're actually measuring, you know, using your test probes between either the positive lead or the negative lead of the radio, between the source and the load? Have you ever used that test before?
I'm not sure what you mean by that. M7 NXT.
Well, they call it a voltage drop test, and I didn't want to really go into that today much because I wanted to just have some more dialogue about other things. But essentially, you can determine if you've got excessive resistance in a circuit that's live. As long as there's current flowing through the circuit, you can take your test lead and measure from like the positive terminal of the power supply to the positive lead at the radio, and measure across that to determine if you have any voltage drop or any resistance. It's somewhat like measuring resistance across that circuit, but the cool thing is when you measure it using voltage, you can see the resistance. In other words, you might have maybe high resistance in the circuit somewhere, or something. Maybe you have a ton of strands broken in the circuit, and you've only got 1 or 2 strands of wire. If you were to take your meter and put it in resistance mode and measure the ohms across that circuit, it may appear to be good. It may be low resistance, you know, 0.03 ohms or something like that, and look completely fine. But the minute you put any current behind it, it can't supply the current, and so you have voltage drop across that circuit. Are you familiar with that process?
Yeah, I have used that in the past. I just didn't use it on this particular instance.
Yeah, I may be confusing some folks on that, but voltage drop tests, I used to use it a lot when we were looking at starter motors. Wes mentioned the other day, or a little while ago, excuse me, about when he would go to use the starter and the voltage would drop enough that the radio would reset. And one of the things we used to have problems with is there some of these starter motors required 80, 90, 100 amps or more to turn over a cold engine, and sometimes if we had too much voltage drop in the leads going to the starter from the battery, it wasn't enough to source enough current to make the starter motor work. So we would use voltage drop tests to measure that. And typically you want to be under a half a volt drop is typically was a rule of thumb. It kind of somewhat depends on the current, of course. How much current's being supplied to the circuit. But measuring from the source to the load in a voltage mode can determine how much voltage is being dropped across that portion of the circuit. Anybody else have any comments about that, or thoughts or ideas?
I have a question.
Yeah, go ahead, Wes.
With your extensive automotive background, I'm sure you have the answer. So is that kind of how they test a battery's health? It has something to do with the recovery after such a voltage drop?
Well, that's probably a little bit deep in the, as far as the subject, but no, not completely, because battery tests have kind of changed over the years. There used to be, back in the day, what you would do is you would take a battery, and you would take this great big resistive load that was basically a big heater, and you would set up on that, you would dial in the amount of current that you want to put across the battery, and you would load the battery down for a certain amount of time, and the voltage shouldn't drop to a certain voltage. Well, they found that basically that was really extremely hard on the batteries, and it wasn't a good way to test batteries. And so over the years, they've gone to different types of tests. Conduction tests, where they actually send an AC waveform through the battery, and they can measure how much basically the capacity of the battery. And I'm not getting in a whole lot of detail, but this conduction test is pretty much how they test batteries today, and it's kind of a slow, drawn-out process, but they have these fancy machines that will sit there, and they'll measure the conduction of the battery across the battery terminals, and then they'll go into charging, and they'll charge it, and then they'll put a load on it for a period of time, and then they'll remeasure that conduction again, and it's got to be within a certain range, otherwise the battery fails. So it's kind of a long, drawn-out process, and it's very interesting. You can find some interesting information out there about how they do it, but most of the modern battery testers today, they don't actually put an actual load across the battery anymore. It's all this conduction-type testing, and I think I'm using the right term. It's been a while.
Thank you. That's fascinating. I just figured they threw a load on it and watched the recovery. Do you want to hear the numbers on my battery?
Of course.
Okay, the Anytone that I'm running, 878, has a great feature. You can program one of the buttons to tell you the incoming voltage to the radio. It's very handy. And I programmed one of the buttons for that purpose. And I left the radio on in the car, running all since yesterday. Oops. I happened to be walking by the car during the net, and I heard it blazing away there with the program material of the net. So I checked my battery voltage. Oh, shoot, we're talking about input voltages. What are the chances, right? It was 11.5. Good, brand new interstate battery. Started the car up. Now, without the car running, my radio is telling me that it's like 13.4, 13.2 already, just for the length of time that the net's been going. Turned off the car, and I noticed that the charging voltage with the alternator jacking energy into the battery is about 14.4. So anyway, I'm glad you brought this subject up because I'm starting to pay attention to actual voltages for a change. Thank you very much. Back to Net Control, KD6EIR.
All right, very good. Yeah, well, it's good to know, and it's good to know what to expect. And I would encourage folks to get out there with a multimeter and do some tests, so you get kind of familiar with what you should see. I mean, when you're transmitting, what is the voltage at the radio when you're in transmit mode, when you're talking on FM or sideband or whatever? I mean, of course, that voltage is probably going to be varying. If you're in sideband mode, it might be a little bit hard to read. At least you'll know that's what what you can expect. You might have a problem in sideband mode and never know that when you are transmitting and you're talking into the radio, why is my voltage fluctuating? You mentioned a moment ago too, Wes, about the voltage coming out of the alternator. That's all well and good, but if you've got a dead battery, that alternator's putting out a ton of current. I mean, it could be, most modern vehicles today are put, anywhere from 80 to 120 amp alternators or even higher, depending on, what it is. So it could be sitting there putting out, 80 or 100 amps into the battery for some period of time with that 14.4 volts on it. So kind of good to know, what's normal. Or maybe you're driving your car one day and you get a battery light that comes on. Well, what does that mean? Is my alternator still putting out? Well, it'd be pretty good to know that before you have the light come on. So, go out, start your car, lift up the hood, put your voltmeter across it. What does it measure? Maybe before you start it, measure the battery voltage and see what it is. I encourage everybody to do that, and it'll help give you some more insight as to what's normal and what's not. All right, anybody have any other comments or questions? This is Jim, AA7CO, the Saturday 4 p.m. social.
10-7, NXT.
Go ahead, Dave.
Yeah, this is kind of my general approach with the cell-type batteries, the AA's and stuff like that. Keep in mind what the purpose is and what the cost is if it fails. Okay, so for instance, the gate opener, yeah, that needs to work. Okay, so if the battery starts indicating low, then I replace it and break it. But for other devices like the wireless mouse on my keyboard or on my desk, if that doesn't work, it doesn't really matter. I just get another battery and put it in. And so what I do is I take the batteries that come out of the gate and put them into my mouse, that kind of thing, to get the full efficiency of using up the battery before I throw it away. So if you keep in mind the use of the battery and the cost of it failing, it kind of sheds a light on how to best use the battery instead of NXT.
All right, Dave, well stated. Yeah, that's a great idea. Yeah, if you're maybe you've got maybe you're swapping out your 9-volt battery out of your smoke detectors because every 6 months you're supposed to do that, or every year, or whatever the case is, and you just do that. Well, maybe you can take that 9-volt battery and use it in your DMM, or you can use it somewhere else that's not, that critical. So, yeah. And I think, I don't know if we ever really did cover it completely, but we were talking about what's good, that voltage. I think most people, depending on what you're using the battery for, if you're running a AA or AAA battery, usually once it hits that 1.2 volts, it's getting pretty darn tired. But again, it just depends. If you're using a single battery, or maybe you're running 2 batteries, and are they in series or are they in parallel? It just kind of depends on what you're using. But very well stated, Dave. Thank you for that information. Anybody else have any other thoughts or comments? Okay, well, we're getting pretty close, or about 15 minutes away. Do we have any other check-ins for the Saturday 4 p.m. social? KJ7OES, mobile. right. Well, good afternoon, Devin. Good to hear you. I got you checked in. Anybody else? All right. Well, we're up to 14 check-ins for today. I really don't have anything else. Well, actually, I do. I wanted to ask if anybody has heard of the voltage drop or the battery drop test to determine whether a battery is good or not. I'm just curious.
KM7DEW.
Well, hi, Dewey. Are you going to answer the question, or are you just checking in? KM7DEW, Dewey, do you copy AA7CL?
Yeah, AA7CL, copy.
All right, I've got you checked in, Dewey. I was just curious, were you going to answer that question, or did you hear it?
Oh, sorry, I did not hear it.
Okay, no problem. I just wasn't sure if you were responding to the question or if you were just wanting to check in. No problem. Good to hear you. Are you just now getting in on the conversation?
Yeah, I've been listening, so, yeah, anyhow, no, the question part, I don't, anyways, I just wanted to check in. KM7DW.
Okay, yeah, no problem, Dewey. AA7CL in the group. All right, anybody else heard of the battery drop test to check to see if the battery's charged or not?
Yeah, I've heard of it.
Have you looked into it at all? And the reason why I asked this, I think it's just kind of crazy, but I was looking at battery voltages and stuff today, just kind of looking up, some ideas and concepts for the meeting today, and I found this. I've never heard of it. I just thought it was absolutely ridiculous. And I think it's not inaccurate, and I wouldn't encourage people to use it, but I guess there's some science behind it, which is kind of interesting. And the idea is essentially you can take a AA or AAA battery, and you can drop it on a surface, and a battery that's fully charged won't bounce, but a battery that's, I guess, undercharged will bounce. And we're talking about 2 to 3 inches or something like that. But turns out there's a whole bunch of videos and a bunch of information out there. There's a little bit of science behind it. I kind of looked into some of the chemistry behind why that might be the case and why that is, but I don't know that I would use that as a means to determine if my battery is good. I just thought it was kind of interesting.
Are you saying that doesn't take the place of that red, green, blue, or red, yellow, green tester that we were talking, that Ed and you were talking about?
It's probably about as accurate. I don't know. No, I think the red, yellow, green tester is probably much better than that, the drop test.
Okay, now speaking of shocks to batteries, should we talk about shocks to lithium batteries? Because I have a story. I haven't looked at the clock to see if it'll fit within the 1 hour time requirement.
Well, we have 10 minutes, so go ahead and tell your story. I'm sure others will find it interesting.
Well, it turns out lithium batteries that have sat for a long period of time will not produce voltage necessarily as required, and they need a physical shock, kind of like that drop test. And I was doing some tech support for security systems. We had these devices called bill traps where you put in a dollar bill or something, stick it in a cash register, and it had a contact where if you pulled that bill out, it would set off the alarm system. And they had these, good-sized lithium batteries in these little devices. They're kind of expensive, a couple $100 for the bill trap, as it's called. So sometimes the battery, having sat not being used forever and ever, stopped working, the system would see that that device wasn't being enrolled properly. So it's a video system as well. So I had the customer, I'm looking at the camera at the person running the caster, the mouth breathing, knuckle dragging clerk, and I said, take the bill trap out. Okay, open the case where the battery is. Okay, I found it. Okay, pull the battery out. Okay, I need you to smack that on the table. So he smacks on the table with great ferocity, not the battery, but the bill trap. It breaks apart into a million pieces, and there goes a $200 device. But apparently with lithiums, you kind of got to smack them sometimes if they've been sitting for a great deal of time to get them to produce voltage. Do you know anything about that? KD6EIR with more cockamamie stories.
That's a funny story. Yeah, I don't know much about lithium battery technology, just basics, what I've read. I remember my dad telling me years ago when lithium first came out, it's like, those things are going to kill you. Don't ever touch them, and boy, make sure you don't get them wet because they'll absolutely blow up on you and blah, blah, blah. But, I don't really know, and I don't know why, shaking them around or, pounding them on the desk or whatever would make a difference. Maybe they're sulfating of some sorts. I really don't know. Anybody else have any ideas or why that might be the case?
KJ7, Zulu Charlie.
Hi, George. Go ahead.
I had a friend of mine that owned a junkyard and a tow service and everything. And he found out that if you take a battery that is pretty much, let's say, not totally dead, but dead, and picked it up about waist height and dropped it on the sand, not the cement driveway or anything. I don't know if it broke up the scale in it or what, but he was saying that battery would charge up full and be good, just like a new battery.
And this is an automotive type, like sealed lead acid type battery?
Yeah, or, one that, what do they call them, serviceable, whether that, that you can put water in.
Yeah, maintenance free or sealed lead acid or whatever. Yeah, scaling and not corrosion, but I can't remember what this, what it is now, but the plates have a tendency to build up scaling on them, and then of course you don't get the transfer and the batteries don't work as well. There's been articles and devices out there that will go in and put pulses into the battery that breaks up that scaling. And I think, maybe there's some truth to it where, you pound it on the concrete or, in the sand or whatever, and it drops and breaks some of that scaling off there. But I think you have just as good a chance as, breaking and, busting up the plates or the contacts between the plates. So, yeah, maybe some truth, maybe not. I really don't know. I certainly don't think I'd go out and drop my battery to see if it works, but I could see where, if you could eliminate some of the scaling on the plates, that maybe that would definitely be a benefit, which is kind of interesting. I do know that, batteries we saw in automotive vehicles that would be in, really rough service, dirt roads all the time, high temperatures, a lot of those would come in with, damaged posts, plates that were shorted, all kinds of crazy stuff just because of the rough usage and stuff like that. But interesting. And by the way, I wanted to mention, George, you do have a little bit of a hum on your signal. I'm not sure if you're connected to a power supply or not, but it's almost probably about half of your voice modulation.
Okay, then I'll wait until I can get that tested. Yeah, I'm right next to the transformer, and I'm transmitting with the antenna on a stainless steel frying pan, so I'll check that out. Thank you for the information. KJ7 to Charlie Charlie, I'm clear.
Okay, George, no problem, and good to hear you. I just wanted to make sure I mentioned that to you. You probably never know it, but I don't know if you've got the radio too close or microphone too close or, RF issues. I'm not quite sure, but it is pretty noticeable. All right, we're just a couple of minutes away. Any other comments, questions from the group today?
N7, NXT.
Go ahead, Dave. AA7C on the group.
So I just tried the battery drop test. I had 3 AA alkalines, one of which was weak. The other 2 are good. The battery drop test worked correctly. The weak one fell over. The 2 good ones both stayed standing up. I repeated it several times. Tried the same thing with lithium batteries, the 18650 cells, and it does not work for that. Or at least didn't work for me. Also, I have a horror story related to expectations of voltage, if you want.
You dropped out at the end there, Dave. A little bit noisy. You go ahead. Yeah, not making a repeater. No, nothing heard at all. Just hash.
Sorry, is this working better?
That transmission was better. Go ahead.
Microphone plug came loose. I need to deal with that. Anyway, I was working on televisions in the 1980s, and somebody brought in their TV saying it was haunted. And what they meant by this is it glowed purple in the dark. Okay? So my thought is that this is too much high voltage going to the picture tube, and I found out when I measured it that yes, it was way too much. Specifically, the high voltage probe was rated at 90,000 volts, and I was using the proper safety stuff. I had left hand at my side, right hand with the probe, wearing tennis shoes, all this kind of stuff. Well, the screwdriver I had in my left hand is still embedded in the ceiling of the place. It broke down the probe. Best guess is 200,000 volts, and I saw purple for about a day.
Yeah, that's horrible. So the purple is probably plasma, huh?
It probably was frying something in my eyes, yeah.
Yeah, that's a horror story for sure. It's a good thing you're still alive. That's just nasty. My dad built TV sets, and he had one that he put together, and about every 6 months or so, a capacitor in the audio circuit would blow up, and it sounded like a gunshot would go off, and he'd go in and replace it. And then one time he left the back of the TV off because he was kind of trying to troubleshoot this intermittent, capacitor issue. Anyway, us kids were playing football in the living room. Of course, that was kind of silly, but the football went behind the TV. So I reached back there to grab a hold of it with on, and the only thing I remember is laying on the ground trying to figure out what hit me. It was horrible. So I survived a stupid thing, but anyway, good stuff. All right. Anybody else for any comments from the group?
You can check me in. I just walked in, WA6IQ. Also on Dave's thing, he undoubtedly got a huge dose of X-rays.
Yeah, that wouldn't surprise me.
Yeah, that's horrible. Okay, John, good to hear you. Yeah, good. I'm glad you were able to check in tonight. Any comments or anything for the group, John?
I don't know what's going on. I just literally just came in back from town, so I'm sorry I kind of missed everything here. Don't even know what we're talking about today. No, the comment I made was when the high voltage gets high in those old TVs, they generate a huge amount of X-rays.
That's interesting. You know, and I thought he said that the picture or the TV was hot and it glowed purple. I'm wondering if that was plasma. Do you think voltages that high was creating some plasma?
I expect it would, but that wouldn't worry me. It'd be the X-rays, and that may be what affected his eyes.
Gosh, that's just scary. I mean, it could just absolutely blind you. Anyway, yeah, so today, John, we just basically talked about voltage measurements and expectations and understanding what it is you're measuring and, you know, why it's important to know. We had some good comments and, you know, thoughts about, you know, measuring voltages and batteries and, you know, voltage drops. We talked about voltage drop tests, you know, and how to measure to determine if a circuit's good, where you might have a resistance or a lead. You're checking, you know, the resistance of a circuit might check good, but when it's sourcing current and using a volt drop test to be able to determine if you've got, you know, excessive resistance somewhere in the circuit. So talked about all kinds of really interesting things and had some good comments and feedback.
Well, I'm sorry I missed that. That sounds really good. Yeah, it absolutely... you need a plan. When you're troubleshooting, you have to have I mean, sometimes you're just at a loss for what's wrong, and you have to just kind of look for something that doesn't seem right. But way ahead of the game if you can anticipate what you're looking for, and so you know if it seems reasonable or not.
Yeah, absolutely. So we talked all about understanding what it is you're measuring and expectations and things like that. So, all right, well, we're past the 5 o'clock. I told everybody I'd try to keep this to an hour tonight. I hope that everybody found the conversation interesting and hopefully useful. I'm certainly open to feedback and other conversations or topics you'd like to talk about, but I think this stuff is important to discuss, and personally, I like doing this. Hopefully, it's helpful. All right. Any other comments from the group before we close today's session?
AA7CO, AJ7 Zulu Charlie Charlie.
Yeah, go ahead, George.
Did that noise go away?
No, it's about the same.
That was my only question. I had a handy copy stuck in my pocket right next to the microphone.
Yeah, it sounds like a power supply issue of some sort. Typical power supply type hum.
Probably too close. All right, thank you. AJ7 Zulu Charlie Charlie on clear. Thanks for the net. Idea?
Yeah, go ahead, John.
I don't know what kind of radio he's running, but if it's like a mobile radio, you might try, if you're on high power, going to low power, and that might answer the power supply question. At with the lower power, you're going to draw less current. You'll have more filtering. Okay, thanks for that. HA7 DCC, I'll be clear.
Okay, George, yeah, I hope you get it squared away there. All right, well, with that, I'd like to thank everybody that was here and participated today. Looks like we've got 16 check-ins today. So glad you were all here, and appreciate, thank SOARC for the use of the repeater today. And like I said, if you found today's session interesting or of value, please let me know. You can either shoot me an email or send something on the SOARC group, whatever. I'm looking for more topics and things to discuss. So anyway, with that, I'll say 73. Everybody, hope you have a great rest of your weekend, and we look forward to hearing you next week. This is Jim, AA7CO, with a Saturday 4 p.m. social, returning the repeater back to normal amateur use. Take care, and 73.